All right, let's try to prove the gamma of odd halves formula, right, which is stated here. All right, before we get started, I'm going to assume that we already have the reduction formula, which is gamma of x plus 1 is equal to x times gamma of x. And also, we already know that the gamma of 1/2 is square root of pi. All right, so let's start with the left-hand side. So left-hand side is gamma of 2n plus 1 over 2. Then we can apply the reduction formula to rewrite this guy as 2n minus 1 over 2 times gamma of 2n minus 1 over 2. And we can apply another reduction formula, and we have 2n minus 1 over 2 times 2n minus 3 over 2 times gamma of 2n minus 3 over 2. And you can see that we can just keep on going through this process over and over, and we're going to continue doing this until you get the factor 1/2 at the end. All right, so it's going to look like this. Right? So the last factor is 1/2, then gamma of 1/2. But since we already know that the gamma of 1/2 is square root of pi, so replace that, we get this formula. So you can see that 2n minus 1 times 2n minus 3 all the way to 1. So all the odd numbers multiply together. Then you're going to have n2's on the bottom, so you have 2 to the n. Then we replace gamma of 1/2 with square root of pi. So we have the formula, right? So just for the heck of it, let's do an example, small example, right? So we can apply this to, say, case n equals 3, right? When n equals 3, we have a gamma of, let's see, 2 times 3 plus 1, so you have a 7 over 2, right? So this can be found. So you go to the next odd number, 5, next odd number, 3, until you hit 1. Since n is 3, you have 2 to the third power. Then we have a square root of pi. So we have 15 on top over 2 cubed is 8 times square root of pi, right? That's how we use this formula to find the gamma of odd halves. All right, that's it. I hope that this was clear.